lines of fit, using a line of fit to model data. Now, if a data set has a positive correlation or a negative correlation, we kind of compared these to a line before. So it either has a positive slope or a negative slope. So what we can do here is we can kind of fit the data with a line that can then help tell us other things about the data, which we'll cover more as we go along. Now, if we want to use a line to fit and model data, we have 4 steps. First of all, step 1, you're going to make a scatter plot of the data. Step 2, decide whether the data can be modeled by a line. It has to either have a strong positive correlation or a strong negative correlation. If there's no correlation, you can't use a line because the data is scattered. Step 3, draw a line that appears to fit the data closely. There should be approximately as many points above the line as there is below it. And then step 4, write an equation using 2 points on the line. The points do not have to represent actual data pairs, but they must lie on the line of fit. Finding a line of fit, example 3. The table shows the weekly sales of a DVD and the number of weeks since its release. Write an equation that models the DVD sales as a function of the number of weeks since its release. Interpret the slope and the y-intercept of the line of fit. So if we're trying to find a line of fit, step 1, create a scatter plot. X-axis, y-axis, I'm going to have my weeks. 1, 2, 3, 4, 5, 6, 7, 8. Week. Then I'm going to have my sales in millions of dollars. It looks like we have to get up to at least 19. So I'm going to count by 2s. 10, 12, 14, 16, 18, 20. And make sure we put sales. And make sure you label that this is in millions of dollars. Okay, so this is really $19 million. And then we're going to plot them as XY. So 1, 19, 2, 15, 3, 13, 4, 11, 5, 10, 6, 8, 7, 7, and 8, 5. Step 2, we have to figure out whether or not a line would actually model this data. So is there a correlation? If I'm looking at my dots, it looks to me like this is a negative correlation. So as the number of weeks increase, the sales decrease, which tells me I can model it with a line. Now, at this point, if you don't have a ruler, you really want to be using a ruler because you kind of have to take your ruler and lay it across the points, and you kind of move the ruler where you're trying to get it either to go through all of the points or you want the same number of points above the line as below the line. So, for example, if I kind of take my line here and I eyeball this, do you notice if I put my line right there, I've got above the line, I've got 1, 2, 3 points. Below the line, I've got 1, 2, 3 points. And then on the line, I've actually got 2 points. Because if I moved my line a little bit so that maybe this part is going down here, well, then I don't have any points below the line. They're all on top of the line, so that's not representative. So I kind of want to have it about right there. I've got the same number on top, the same number on bottom, and then it's actually hitting 2 of the points. Now, at this point, we have to pick 2 points on the line. Well, given that I specifically have this point and this point, which are in my data set, I could also use this point, but it's not in my data set. I could use this point, but it's not in my data set. I'm going to use the 2 that I have, which are the 5, 10 and the 6, 8. And we have to create our line. In order to do that, I'm going to use y equals mx plus b. I'm going to start with my slope, which is the change in y over the change in x. If I look at the change in y, I go from 10 to 8, so 10 minus 8. The change in x is from 5 to 6, so 5 minus 6. 10 minus 8 is 2. 5 minus 6 is negative 1. So I know my slope is negative 2. Then I'm going to come back and I'm going to do y equals mx plus b, which I don't know the y-intercept. In order to find that, I'm going to pick one of my points. So the point I'm going to pick is 5, 10, and I'm going to substitute it in. Y is 10 equals negative 2 times x, which is 5, plus b. That's going to be 10 equals negative 2 times 5 is negative 10 plus b. Then I'm going to add 10, which is going to give me 20 equals b, which is then going to get me y equals m, we know is negative 2, x plus b, which is 20, which is the equation of my line of best fit. Now, it says for that line, and actually if you look at that, plus 20, that's your y-intercept, doesn't it look like that might go through 20? So, interpret the slope and the y-intercept of the line of best fit. So, the slope we know is negative 2, and we have to interpret that. So, that tells us that sales are, first of all, decreasing because it's a negative by about $2 million each week. Then we have to go look at our y-intercept, which is 20. Now, if you think about our y-intercept in context of this problem, that would mean at week 0. Well, week 0, there's no actual sales in week 0 because nothing was happening. If we look at our data, there was nothing happening there. We didn't have sales until week 1. So in the context of this problem, 20 doesn't have a meaning. So does not have meaning for this problem because there's no week 0. So 20 is just simply 20.